For want of a better term, a gas which is radiating strongly because of coherence will be called superradiant. If the wavelength of the light is much greater than the separation of the emitters, then the emitters interact with the light in a collective and coherent fashion. Now we look at emitters in this context with the discharge, my back, of a xenon bulb, and here we get some strange looking plasma discharge at the highest level of operation. We also note that at the two lower levels of operation, the secondaries will function to pick up neon discharge, those secondaries between each of the bipolar designed pair of resonant alternator Tesla coils. Well, we're just going to show on the first, second, and third level. And on the first level we have an 8-volt open circuit. On the second level we have a 11.3 open circuit. And on the final output we have 21.8 volts on open circuit. All this is accomplished by two 4-ohm resistors, large industrial 4-ohm resistors, and we have a short wire there that if we take out, eliminate those two 4-ohm resistors on our solid state field input device to the field of the alternator, that will give us a full 7 volts to field, and then we obtained specified 21.8 volts open circuit performance of the 3-phase alternator. Okay, without further ado, we'll get these things rolling here and turn it on. Looks like it's none of the resistors are, the two resistors are in place. The field is not turned on, and we'll see if we can capture our three necessary parameters of function here, which are the 3 stator voltages and the 3 stator amperages on the 3-phase process. We're turning it on. Okay, there we got generally 1 volt stator outputs due to the rotational magnetism of the field rotor before any field energy is being engaged. And we got 0.15, 0.12, and 0.22 amperage circulation on phases 1, 2, and 3. We're going to quickly go in there and engage it to the lowest level of 8 volts open circuit by ballasting, taking one of the 4-ohm resistors out. Okay, we got the field on. That's what we get with the field on. It reads 8.5 volts, 10 volts, 8.3 volts, 2.3 amps, 0.99, 1 amp, about 1 amp, and 1.6 and 1.7 amps on phase 3. Now this process is powering a neon bulb taken from the two nearest coils placed in series over the poles of this 666 machine, which provides the secondary voltages we need for applications such as the Tesla coil, where here we have, instead of a Tesla coil, it's simply powering a A neon bulb. There's only about 120 volts across that. We're not gonna fool with that this year yet. What we're gonna do next, we got the secondaries draping down from our bipolar Tesla coil pair, and we want to focus in there. And right now they're in parallel with a krypton bulb. Now we're going to take out the neon bulb in front and let the krypton bulb receive the voltage. And as soon as we do that, we see that now the krypton acts like the primary of an arc gap, and it imparts energy to the secondary coils. So this is stage one. Try to get a close-up of that arc if possible. It seems to fill most of the filament of the tube. And we'll look at our power output there. I don't like this at all. No, I don't really like this at all. I just put voltage meters in the top 2 meters. We're supposed to be operating at 8 volts open circuit, but all of our voltages are above open circuit. It's reading 8.6, 10.1, 8.4, and we got 2.3, 1 amp, and 1.7 amps on that primary consumption. Now we're going to go up one level and go back to the discharge itself. We'll be going up to what is nominally an 11.3 volt open circuit. This by shorting out the second ballast. Well, I could be wrong. We're already in the second stage. That's okay. We didn't show the first stage. This is somewhat of a classic now, because I've noticed this effect before. After prolonged operation at this 11.3 volt stage, the secondary action seems to want to stop. So what we didn't show to begin with, because of disorganization, is the operation at the lowest level, which is in fact the 8 volt open circuit. I was quoting this as 8 volt. It was an 11.3 volt open circuit, actually. So we're going to take the ballast off now and watch what happens with our secondary discharge that apparently has ceased. Right now we're at 10 volts and 8.5 volts. Now, as we can see, we went down to the lower level, but yet the secondary started picking up, and our input levels now reportedly from the 8 volt open circuit, 6.3, 7.4, 6.2 volts on the 3 phases, 1.6 amps, 0.8 amps, and 1.2 amps on phase 3. Now we're going to go back up, finish this thing out. We've showed that the krypton discharge can, at the higher levels, can stop them secondaries from emitting their voltages. We're going to turn it up to the highest level, which is a 21.8 volt open circuit state. Now, as we can see, the secondary discharge ceased, and through the camera that doesn't look very much like I seen earlier in sunlight, where the discharge was actually looking in a pulse form. So we'll try to get the best close-ups we can of that. Wait a minute there, I thought I seen something. Well, post-discharge, I can visually see the post-discharge in this lighting. I don't know if the camera will be able to see it, but we'll go back to our power inputs, show them, and close out the video. We have 17.5 volts, 20.5 volts, and 16.8 volts, 0.47 amps phase 1, 1.7 amps phase 2, and 3.6 amps phase 3. Characteristically low amperages for this highest level of output. Okay, thank you very much, folks.